Here's a few questions on inverse functions. The first question, and we'll do maybe a couple of these, graph the equation by substituting plotted points, then reflect the graph across the line y equals x to obtain the graph of its inverse. So they first want us to graph this line. So x is equal to y squared minus 3 by substituting and plotting in points. So let's do x and y, and we'll do our graph over here. So since the graph is solved for, oops, that's a little odd, sorry. Since the graph is solved for x, let's plug values of y in. Okay, so let's plug in -2, -1, 0, 1, and 2. Those are my favorite to plug in. So if I plug in a -2 here, squared minus 3, what does x come out to be equal to? -2 squared is a +4, minus 3 is 1. So that'd be 1. And then plug a -1 in, -1 squared is 1, minus 3 would be a -2. Plug a 0 in, 0 squared is 0, minus 3 would be a -3. Plug a 1 in, 1 squared is 1, minus 3 is a -2. 2 squared, hey, that'll be the same, that'll be a 1. So if I plot these points, 1 and a -2 right there, -2 and negative, well, hold it, this should have been a -1, right? So -1, no, what number did I have there? It was +1. Anyway, if I plug in a +1, I get a -2, that's right. And -2, -1, -3 and 0, -2 and +1, 1 and 2. Did I put a 0? I didn't. Well, I see what I was doing. I keep, when I plug in a y value, I keep mixing up what the x values are that I'm thinking I'm plugging an x in. Anyway, I think that we're all good there. It'd be interesting to know what, I don't know if I could find out, I'm looking for a value in here somewhere, but it looks like the graph is doing this. And I sort of knew that because it's a y squared. If it's a y squared, it's not going to be a function. So a vertical line would hit the thing twice. So it's not a function, but it is a relationship. Okay, so then they say reflect the graph across the line y is equal to x. So let's put that line like this. Let's see what that was, 1 and 2. So I think my line would look sort of like this. That's y is equal to x. That line right there is y is equal to x. So to reflect, all I'd really have to do, and I could do it graphically, or I could just do it numerically. So if I pick these points here, and maybe I'll do another graph. So let's do an x and a y, and then inverse function, all these points would just swap. So x is -2, y is +1, -1, -2. And all I'm doing is swapping these around. So 0, -3, 1, whoops, 1 and -2, and then 2 and 1. And then I can just plot those points. -2 and 1 be about there. -1, oh no, -2 and 1 is here. -1 and -2 would be about down there. 0 and -3 would be about here. 1 and -2 would be about there. And 2 and -1 would be about 2, -1 would be about there. So this graph is looking like, yeah, that's not a point. This graph is looking like this, something like that. And so what should be happening is all the points on the blue graph are inverses of all the ones that are on the black graph. Okay, hopefully that helps you. So this line here, maybe I'll put that line in red. This line here is the reflection. So if I see a point on this graph there, and then on this graph, I have a similar and analogous point, or a reflected point. And any point should work like that. Like this point right there is a reflection of that point right there. And it's a reflection over that y equals x line. Okay, similarly with this next graph, x plus 2 is equal to absolute value of y. I'm just going to rewrite it so it looks a bit, to me anyway, a little bit easier. Now, trouble with this one, I think, is that you could come up with multiple solutions. But let's just try some and figure out what we come up with. So let's plug in x values, plug in y values. So let's plug y values in because there's an absolute value sign there. Again, let's plug in y values. That's going to hurt my head like it did up on this one, but let's try it. So like -2, -1, 0, 1, and 2. So if I plug a -2 in, I'm going to have to write this out. So if I plug in a -2 here, and I need to solve for x, absolute value -2 is +2. And then to solve for x, I'll subtract 2 on each side. So I'll get x is equal to 0. First point. Next point, let's plug in a -1 here. So absolute value, I'm just going to do it on top, I'm short of room. If I put a -1 in there, then this will be a +1. When I subtract 2, this will be a -1. Okay, if I put a 0 in, 0, absolute value of 0 is 0. 0 taken away -2 is a -2. I don't mind putting stuff on top. Maybe I'll do a different color. Let's put a 1 in. So if I put a +1, absolute value of 1 is 1. 1 take away 2 is a -1. And finally, put in a 2 in. 2, absolute value of 2 is 2. 2 take away 2 is 0 again. Now let's plot those points. So we'll do it on a graph. I'll go down a bit. So if I plot those points, 0, -2 is my first point. -1, -1, next point. -2, 0, next point. -1 and 1. That's sort of funny, eh? And you can tell it's not a function because for the same value of x, I'm getting different values of y. And 0 and +2. So it looks like there is my initial function. And then to figure out where the reflection is, to figure out the inverse function, here's my y equals x line right through there. And to do a reflection, that's sort of an interesting reflection. To reflect this point here, it would be right over here. To reflect this point, it'd be there. So this whole line sort of stays till it gets to right there. And then all of these lines here, that's on the reflection line. So it would just go like that. And this one keeps going this way, so this one would also keep going that way. So my reflected graph would look like that. And if you wanted to, you could just take those points up there and swap them around. So instead of 0, -2, you'd have -2, 0. -2, 0, that'd be your point right there. Instead of -1, -1, oh, it'd be the same. Instead of this one, you'd have 0 and -2. Okay, hopefully that helps you with graphing those. Now here's one other question to look at, and this is looking at a graph and trying to get the reflection on it. So I know the reflection's got to look something like that because I'm reflecting on this line here. But I'm not exactly sure where it would be, and I might want to be more particular. So what I could do is just find points. So to find a point, here's a point right there at 3, 0. So the inverse of that would be 0, 3, which would be this point right there. Let's find another point that might be on that line. Maybe this one right there, 0 and negative 1.5. So 0 and negative 1.5. So that would translate to negative 1.5 and 0. Negative 1.50, that point right there. Now this point that is right on the y equals x line, and it's on my function line, that's got to be the same for both of them. And then I could find another line that's down, another point that's down here somewhere. I don't really have a good scale to look at, so I think I'm just going to call my line like that. So that would be my inverse line. All right, hopefully that helps you with those questions on inverse functions.